So it looks like most of you have already taken your seats. My name is Val, and in Yandex I deal with the databases. Today I'm going to tell you about our paying bicycles for finding a large number of connections and links. I like to store it from the moment. Why? It is the reason, the problem. Why should we say on this? There is some evident things, and those who are using Postgres, you know this, because Postgres is using processing model. Every connection, it creates a separate instance in the system. And these instances are not free, although we have 4 clone cheap calls. And of course, on background we cache a lot of useful information, the catalog, the table times, where they are located, the writes, what operations we are able to commit and execute, etc., and so on. There, in the private memory of every backend, we store a compiled PSQL code. And there, with some limitations, we store a distributed request plans. The cake of all this speeds up the requests, and the more backends we have with cake information, the more memory it uses on your server. But there are some things that not everybody is thinking about it when working with Postgres. There is some proc array. This is an array with a backend, and as we have a competitive access, it is protected with proc array lock. And every time you take an MVCC snapshot, it's a statement. This uses a shareable mode. And every time you commit a transaction or open up a new connection, so you fork a new backend, it actually is taking an exclusive access mode. Thus, we have a conflict here. This is a bottleneck from the efficiency and performance point of view. That is why we're trying to optimize all these things in all the reports, on millions of debates on Postgres is actually an attempt to overcome this problem. But the fact is clear: the more connections you have, the longer it takes under the lock. And if we get everything together on one slide, you get the more connections, the more memory is used, the slower all other operations work, and all the requests that you repeat in this current connection, so the processing time will be faster. Probably the most evident time as a solution is to use the connection pool, so you can open up only in case of necessity and open up it in case you need it. For example, you can add it on the side of a database, software, or somewhere in the middle, or at both ends, both sides. Let's discuss the advantages and disadvantages. The applications connection pool, you can do it in any case because it's extremely useful as you keep connection live. At least you will not have to do the authentication every time you make a request. It is quite cheap in any programming languages, and there are specific tools for this. But unfortunately, it does resolve specific problems, but not all of them. For example, when you have a lot of application servers, let's say you just try using Python language, and you have a high CPU load, and that's why you use not the thread scalability, but processes, and you may start up 60 or 70 processes, and each will open at least one process, one connection. You have one server, and you've already opened 60 connections, but you have hundreds of such servers. That's why you're talking about tens of thousands of different connections. And the situation gets even worse if you get a lot of database servers. You have a lot of data, you split them up to 100 shares, and every backend will open up at least one connection to the database. And if you multiply the first part by the second one, the situation gets even worse. Application pool is great, it's cheap, but it will not resolve all the problems you may face. All other options, that is at the database side, somewhere in the middle, is just actually using the external pool of connection, and the Postgres doesn't have one. Historically, the market has two great problems that is able to do that. This is PG pool and PG bouncer. They've been there on the market for a long time. Every solution has its advantages and disadvantages. But at the moment, I'm not going to go into detail and talk a lot about that. We've personally selected PG Bouncer. We really like that because it doesn't have the feature, a bunch of features, but it really does great with the connection feature. It's like a hammer. It can only hammer the nails into the wood. It can do only this thing, but it does it great. Also, the performance is great. It's great because it's a single thread, but it uses either that, it's completely asynchronous, and even using one core, it manages to pass through 1,000 connections. It doesn't parse all the requests and doesn't fork the processes. That's why we decided to go by PG Bouncer. We use it everywhere for quite a long period of time, and we are more or less satisfied. And we almost always use it in transaction polling. And everything is great with it, but not quite. Now the problems you face when using external pooler. We're going to go by PG Bouncer sample, but probably I believe PG Pool also is subject to the same problems. Problem number one is it complicates diagnostics. You have a great clean ADDR account and client house name. You can see the source of the connection. But if you have PG Bouncer, then in PG stat activity you'll see localhost address, and that's it. It will greatly complicate the troubleshooting of network issues and complexity. And you will have, well, great challenge to identify, well, third-party connections. For example, a few years ago, in order to access Postgres, we actually identifying missing connections, or we get some protocol-relevant messaging because probably they interpret the protocol the way they want to. And in this case, it gets quite difficult to troubleshoot and actually backtrack this data. You can actually run TCP backup in Postgres and TCP dump from the PG Bouncer to the base to the server. It's extremely challenging. You can sneak into one specific session. In PG Bouncer 1.6, we get a new feature that is called application name and host. When you switch it on, in the client ADDR, you will see some additional information, but at least it puts the originating IP. It actually, before making every request, it runs the application request form, but this will decrease your productivity and efficiency. Probably you will not be able to see it here, but so this line of, I don't know how to call this color, is actually the amount that goes into the bouncer, and this one is actually what we get into the database. And the difference is, well, there is a double difference. This is quite useful because we see that we get some diagnostical information requests, but on the other hand, it decreases productivity. The next problem we faced is PG Bouncer can be easily adjusted to all different things, timeouts, connection restrictions, connection counts, but all these restrictions are applicable to PG Bouncer server. But if we're talking about client connections, you have only one limit. This is a general limit to all clients, max client count. We have like 20,000 limit set, but when you have hipsters with a poor driver, with leaking connections, it may open 20,000 connections to the database alone, authenticate, and then it can actually maintain the connectivity, and all other customers will get max client pool con error. And I'm talking about one specific application that may do that. The best thing, we decided to apply a patch. We limited a max connection per client per pool, and the pool in PG Bouncer is a connection to one database by one client. And if, for instance, the guys from NGS have leaking connections, all other applications will not be affected. They face the problem and they will get error access error, but no other client will suffer. The next problem we faced is, for instance, despite all the flexibility in connections and settings, we have one problem. For instance, for one database, we may enable one user to create 200 connections, or for the other one, we want to send 10 connection limit. But when using PG Bouncer, you can set either 10 or 200 for everyone. You cannot differentiate between different clients. Fortunately, you can do that with Postgres default features, but the problem is when we use all 10 or 200 connections and the client is trying to connect to make an additional client, he actually gets the information that number of connections limit exceeded, but the client gets the database connection error, and it's quite difficult to tell the way it shall process it from the client logic's point of view. It means that PG Bouncer does not process different network errors correctly. And clients are able to process, but nonetheless the client gets no code, and in order for you to understand what's going on, you need to go into the text message, but you will not be able to identify the exact error, the exact reason. That means you do not have any idea what is going on. The next problem we faced was actually identified when we updated to 9.5. The problem is, it's just PG Bench shots and different Linux versions with different Postgres versions, and you can see that 9.4, the productivity is something like 45,000 transactions per second. 9.5, it just decreases, 2 times, and 9.6 recovers to the previous value. Therefore, we made a report on the decreased number of TPS. We send out a bulletin. We decided to collect all type of diagnostic diagnosis and run all the checkups and verification. We identified for 9.4, to read from socket, we use the select command request. In 9.5, they use a non-lock pool, and in 9.6, they switch back to epool. And they just identified where we go to switch to pool, everything goes terrible, but when we switch to epool, everything is fine. Probably it's like a core engine kernel problem. You can use this, you can follow this link, and you can see the different discussion about the way we ran the diagnosis and actually analyze the problem, and the way we found the solution. Actually, it states that different kernels demonstrate different productivity or TPS decrease. Therefore, we decided to use epool in 9.5, introduce in 9.6. That's why we did the backport of the epool, and my colleague Dmitry was the one who actually backported this epool. At the moment we are moving to 9.6 and everything is fine there without any patches. The next problem, this is a dashboard screenshot for one of our Postgres servers. So you can see the timing graphic response from the base, and you see that it drastically decreases, everything goes down, and we decided to identify the problem and find the solution, and we found nothing strange about this. PG Bouncer is stuck into this one core, one kernel. Yes, it's asynchronous, and it actually takes up the whole kernel core. potential. That means you need to use more PG bouncer because one is not enough. You need to use more. But frankly speaking, we just wanted to make it transparent for our customer, for our clients. If one client accesses host port, we want this client to use it the same way because we do not want to start up or hook up different PG bouncers at different ports because we don't want the client to find out which PG bouncer to use. And head proxy was one of the evidence solutions. This solution is widely used worldwide in different situations, and it works fine for us. And all these three triangles are on one machine, one PC. You get like HAP proxy, we get PG bouncer, we get the number of PG bouncers in Postgres. But actually, it was not that popular. We decided not to keep it up. On the one hand, it's transparent for the customer clients, but on the other hand, it actually challenges the troubleshooting because you have all these connections from localhost, and it's quite difficult to measure bouncer and proxy logs. Secondly, it's yet another part that may fail, and it fails in a strange way. For instance, it knows absolutely nothing about Postgres protocol. If you have Postgres Merv and PG bouncer is launched and running, it will open a lot of and send a lot of connection, and PG bouncer will respond with a bunch of errors, cannot connect or something like this. But the PG bouncer will keep up running PGP and TCP session until it uses up all the resources. So this didn't work. At that point of time, we remembered that starting from 9.3 kernel of Linux, we get like SO reused port. It's like a socket property enabling us to use one port, one address, and listen to several applications. There are some limitations. The way we shall read from a SO socket, PG bouncer fortunately reads it correctly. It just sends different TCP sessions to different bouncers. It doesn't send different packages from different clients to different addresses. So PG bouncer uses or listens to the request at one port. It's quite convenient. Client send requests. They distribute it throughout the bouncers, and bouncers open up the required number of connection to Postgres. Disadvantage is the more bouncers you have, the more idle connections to the database you get. Just imagine you have a client or three clients that open up three connections and make requests every minute. When you have one bouncer, you get one connection to the database. But when you have three bouncers, and when you get all three connections to different bouncers, you have three sessions that actually are idling and are used only once a minute. But bouncers keep these connections live in order to speed up the process. This layout worked pretty much fine, but all of a sudden we changed the reality of our network infrastructure, and we needed to shift encryption to different solutions. So we used like TLS and bouncer. We tried it up, and here we face that all three bouncers show 100% CPU usage. So why is it so? First of all, you can see that they re-establish connection all the time. If we do the go without SSL or with SSL, the difference is 20 times. So it shows the 20-time difference, because with the handshake and with the initial information exchange in order to start the encryption is quite costly if we talk about the processor resources. And here we see the OpenSSL function. Despite all the support of hardware and software, it actually doesn't mean it is still expensive and costly. So what problem we have? Usually it shows when the database opens up for the load. We just reload the master, we reestablish all the connections, and we make it available for load. And at this point of time, clients see that the database is live, and all of them start setting up the TLS connections at the same time. But they are quite costly. This also means that some applications have strict timeout settings, let's say like 100 milliseconds. So you have 100 milliseconds in total, and the application will not wait for connection to the database for more than 100 milliseconds. But actually, the processor will not be able to do the handshake procedure all this time. It happened to be the way. I don't see whether you see it well. We have 16 bouncers running, and they just, use 100% of all the processor time. When you have like 22 cores, half of the cores are used with some garbage instead of processing the connection requests. And the problem with timeout was resolved by shifting the timeout settings whenever possible. We also changed the connection conditions and settings. But in general, 16 bouncers are required to balance the burst of connections when a database opens up. It's a typical number of sessions, like several hundred sessions. You multiply by 16, then you get a few thousand, and the database will not actually manage this. That is why, whenever we need to use 16 bouncers, but when you want to keep up the idle session, for these purposes, we generated this monster. Client comes with a TLS. Everything is still fully transparent for him. He just connects to one port with a great bunch of bouncers. And in general, they do not consume 16 cores. They consume it when we experience the burst of peak loads. We have like 1 or 2 bouncers. It goes through the local host, but not through the Unix socket. Therefore, we have no TLS. And bouncers open up the connection to Postgres without TLS, as we are running on the local host. And despite this looks quite strange and weird, it does resolve our issue. It's still transparent for the client. It is able to cope with any load from 32 to 56 cores. Of course, we're going some decrease in performance, but nonetheless. And it actually enables us to control the idle session count. Disadvantages. Here you get a number of additional elements, like different dozens of elements. You need to manage it. You get a supervisor who will launch and who will deactivate them. Moreover, you have an increased servicing complexity. Second problem, we do not have any load distribution or balancing control. For example, you do not control use port, SO use port, so this idle element has no control over the connection. So actually the one who can make the first request will get the resources. And that means that you cannot tell that this client will use these 4 bouncers to connect to this database, the next one will use these 4 bouncers. It will not work. It works in a different way.
And for this core process, we can't influence anyhow. Next thing, which is not just about bouncer specific, but still we have to find a way how to handle it. So imagine that you have a box solution with the closed code that you can't change anyhow, and it can connect into database with one string. And if we send it to the host with a database where master is, if we switch master, everything will crash. That's why, of course, it's not just one machine, there are several behind the balancer, and we add this into the configuration. And since the client is enterprise and box, it is written on Java. We have JDBC, They use prepared statements, and there is session pooling. And it is written something like this. So when you get this from this base, just forward it to these components. If master dies, what happens? The machine changes the host in configuration and reloads bouncer, and does it automatically. All new connections are opened to this host. What we get? We at least support read-only loads, and read-only queries are at least executed. In some time, automatically or manually, we switch master to a different machine. We switch from A to B. We switch other machines. The cluster is okay. We write new hosts in the configuration. We renew the configuration, and connections are going to a new host. But in a session pooling, if you don't close the connection, it will be still used. That's why part of connection will go to a new host, and part of connections will still go to this replica. So these are connections that we had opened, and bouncer didn't close them. And frankly speaking, we have PG bouncer with some number of changes from ourselves. Support of different bouncers on one port, to survive multiprocessor loads, capability to limit number of connections for a specific pool, and a connection interruption in session pooling if some of critical parameters, hotspot or DBN, is changed. Also, there are a couple of specific things for index areas. I will not cover it, and I believe this can be useful for someone as well. And why don't we share it in open source? I don't know why. Have you ever imagined if, for example, you run a query and it's very long time of execution, you decide to cancel it, and you push Ctrl+C, and normally the Postgres will open a new connection without authentication, and it will say, I would like to cancel the query, and will send the secret of backend that needs to be closed. This is how it should be done in terms of clients. You can find more detailed information in documentation. What will Postgres do? Postgres will put a flag in the memory, the flag will be checked, and then the query will be closed. Most of clients will not do so. Most of clients will send TCP reset, will just close the connection. And if it is connected to Postgres directly without poolers, Postgres will not try to read something from the socket until the query is executed. Then it will try to write the result in the socket, and it will not be able to do so because the connection is closed. But if pooler's connection is the client for Postgres, you can do it there, and in PG bouncer for some time, a year or even more, we have a pull request to implement this feature. There was a patch, it was reviewed several times, but still we have nothing, and maintainers are reluctant to do something with that. We tried this patch, it didn't work, and we fixed it 4 times. We got tired to deal with it, and our previous alterations with the bouncer codebase it's not a very pleasant experience, and we have decided that PGBouncer is a good solution. It works right now, but frankly, we would like to have something better. Namely, we would like pooler to scale across cores. We don't want it to be a single thread, and we would like to have this fine-tuning. We would like to have this kind of transparency. We would like to have this flexible limit tuning. So we would like to make it even more flexible than PGBouncer. Also, if it is possible, we would like to have a client session tracing, because sometimes I have to look at the strange behavior of JDBC or odd clients of odd versions. Probably it will be very good if you don't choose between transaction pooling and session pooling, and pooler decides for you that in this connection we open a transaction and we need to maintain it until it is closed, or create a temporary table until the connection is down. Error codes and something else, but I think you can add even more things than I do. And frankly, for some time there are arguments whether to implement these features in Postgres or not. There is no some people are ready to do so, some people are reluctant to do so, but nothing happens, and I think it will appear as a standalone product, because the capability to place it between the base and the client, I think this feature will never appear in Postgres. That's all. Now I'm ready for your questions. Thank you for your presentation. It was really interesting. The 79th request was sent by mail. What didn't work? We can tell you in private messages. We took it as a ground, we tried to find a workaround, and still we failed. Let's discuss it after the presentation, if you don't mind. Could you tell me about the state of the PGBounce project? I've heard that PGBounce is a child of Skype project. Is Skype still interested in project? Will project die or not? Well, it's very tricky. We started with PGBounce 1.5, there were no significant changes, and then suddenly we saw that Macrocreen became an employee of second quadrant, and the project became alive. And now they're preparing 1.8. So we have plenty of features in 1.6 and 1.7. If they deal with the problem of scalability across cores, it will be just great. But the code uses a lot of goto, a lot of variables, and scalability across nodes, apart from this dirty hack, it is very difficult to do so. We need to rewrite at least half of the code. Thank you. If you are using transaction pooling, and sometimes we face the problem that if we don't send at the end of the transaction a commit into the database, the connection is in the idle, and nothing works, and there are no standard ways how to do so. Do you face the same problem? Yes, we do. For current versions up to 9.5, we have a workaround, contacts, that can trace it back. And in 9.6, we have a very good parameter, idle and transaction timeout. You can use that. Okay, thank you. We'll try it. So we are moving to 9.6, and we will use this workaround. So -1 problem. Can you tell me? I read that there are modules for Nginx. Have you tried them? to solve your problems or not. Yes, we considered Nginx as one of the options to make a good puller, and we had some progress, but the problem is there is no classic pooling. Nginx can start several workers, we will need more than one eventually, and among workers pool will not be shared. Second thing, Nginx is focused on HTTP with very short sessions. In Postgres, sessions are long, and because of that, there are some tricky details. Dmitry, if he is here, was dealing with this problem, and he had some progress. So, select one to database worked, but still there is a lot of work to do, and it's not so easy to do so. Hello. Have you tried to install Bouncer on front ends and not on the back end? If you have a Python with a lot of workers, yes, we can install Bouncer on it, but still, eventually it's a pull on the application side. If you have hundreds of backends, it doesn't solve your problem, because you have 150 machines and at least you have 150 connections to database. That's it. How often do you see master crash? Yes, it happens very frequently, but we have automatic tools that switches master. If we can't do it without data loss, it will do it. If not, it will just prevent the split of data in the future. It was about proxy. Is it because you couldn't switch it as you wanted to? Because proxy has a flexible system to do the check all that will send back the result. So in Avita we write a lot of interesting things. So HA proxy could know where to go. The problems with the diagnosis are still there. Maybe you can write a script to switch. Oh, yes, we can use check that understands the EPQ protocol. Yes, probably we can do so. But it still solves just a part of problems. This patch with review port is easier than the check for HA proxy. You said it's not very manageable. You can't manage it. Can you? So you put it down and you don't know how to distribute it, and I think that HA proxy is more flexible in terms of manageability, but still you can't control it on the application side. You won't be able for a specific user to forward it to a specific bouncer, because HA proxy, because the protocol isn't aware of the HA proxy. You will still have more control, but the logic is still like in the core. A SO-release port can distribute connections very efficiently. At least we have it. We didn't do any specific things to do so. So we had a patch for PGBouncer, and all TCP are closed by proxy, and all other connections are closed by PGBouncer. So we can discuss it if you want to. Thank you for your presentation. Can you tell us how long connections do you have after PGBouncer? From 100 to 500. After 500 we are facing problems. The previous generation 32 cores, new generation of servers 56 cores, but typically we launch several Postgres instances on one server. So You have PG bouncer in all the connections. Yes? Okay. Yes. As for client connections, there are around from 5 to 15,000 connections. Very stupid questions. Have you considered to write your own PG bouncer on Go that will enable you coarse scalability and you could easily integrate your own logics? We didn't consider writing something on Go because we don't know how to do it, frankly speaking. And actually we started the project on C, but I'm not announcing it and I don't commit to anything because it can fail. It comes to the stage of testing. If it is okay, if it works, and if it is integrated into the production environment, we will share it with the rest of the world. But still, I can't promise you anything because it can fail. Have you faced the problem that PG Bouncer doesn't support any startup parameters? With JDBC, it is solved in the upstream with extra flow digits. It is switched off on the PG Bouncer config. With the rest parameters, no, have never met, so. Do you mean when you can put not only application name, but something else? Yes, okay, I got you. Yes, we face this problem. We understand this is the architecture limit and you can't do anything with it. Question about redundancy. When we send something from the PG pool 2 or PG bouncer, you said that this is the single point of failure. If, for example, you run PG bouncer on the same machine and you have several machines, you have replicas on the same machine? No, of course, different machines in different data centers. So how you what do you do with this single point of failure? Data center is our single point of failure, where we have one rack with one server, with one Postgres running, and one PG bouncer. This is our one single point of failure. It can start from the PG bouncer or Postgres instance, or it can be any kind of failure in the data center itself. So there is no difference. When bouncer starts the session, it does it in a sync mode and it sends query. You can put anything. You can use your script, your function, yes, but not very accurate for the user. Maybe yes, maybe no. We are playing with parameters and sometimes we set them on the Postgres side. So we set them, for example, different log timeouts for different roles. And also you can write in the config, you have connection string and you can put user-specific information in this configuration. So we can do it like this, without dividing them by user. Do you ask something from app developers? Yes, we ask them not to send TCP reset. Now, in terms of queries to databases, there are some features that are eventually session level, and PG Bouncer will not be able to route this. Well, frankly, a lot of people who are starting to use Postgres after other databases, they are strongly they're confident that it will be freezed. Yes, it will be a little bit slower, but not so significantly. And in some cases, we can persuade them that you should not use prepared statement or read logs. You will switch to transactional logs, and for some things, yes, we need to discuss it, we need to agree over it. Of course, we would like to forget about all these problems. You've got a lot of connections, but it's your problems. If you want to have fewer connections, okay, don't open it so many connections. That's it.
Thank you very much for your report. So, in order for you to have a new slide when you're switching between, could you please repeat the question? You have two slave servers. You switch to one in order to do the read bar, and then you switch over to the other one. Do you do it in grid before you do you warm it up before you promote it? Now, we use the master and replica configuration. They are absolutely the same from the hardware point of view. That is the way we're trying to do it. And you have cache at the level of operating system cake by the rollover process. I'm talking about the startup process that applies the changes from the masters. That's why all the PG warm for all the blacks that are red on the master, we do not use this. They will warm up on their own within the first 5 minutes. We do just till 200 and then we increase it. But during the hot swap, we don't have it. We're lucky. If we do not have any other questions, we have 10 minutes to have a rest and wait for the next report. Thank you very much for your report.